Alrighty. So this section is a little time consuming. Here. So basically what we're gonna do is use the first and second derivative tests, the ideas of intercepts, maximum minimums, inflection points to help us kind of guess our way through a sketch, a rough sketch. Which so basically is if you needed a graph and graphing calculators did not exist, this is what you would do. Okay. Just get a rough sketch. So I prefer using graphing utilities personally, but there will be one question where you have to go through these steps on the exam over chapter 4. So let's go ahead and do it. But the good thing about it is it makes you kind of have to use all the skills from chapter 4 at the same time. So it's not pointless. At least it's good for practice. Okay. So let's get started here. Let me find some notes here real quick. Okay, here we go. Summary of curve sketching. This is number 1 from 4.6. Sketch y equal to x over x squared plus 4. All right. So the first thing we should do is just go ahead and find the x and y intercepts. So step 1. Find x and y intercepts. Just a quick review. To find x-intercept, let y equal 0. So basically set it equal to 0. The only way this would be 0 would be if the numerator is 0. So you can actually just set the numerator to 0 for these types of functions. But there's nothing to do, so intercept is 0, 0. Okay. To find the y-intercept, let x equal 0. And just basically solve. So if I plug in 0 for x, you would get this, which would be 0. So it turns out that the y-intercept will be 0, 0. All right, so there's the intercepts. Turns out it goes to the origin, which is not that interesting. Step 2, find the critical points. To save time, I'm going to skip the derivative step, since we've done those quite a bit all semester. Once you do it, you would end up with negative x squared plus 4. And once you polish it, do some algebra, you'll get to here. Now, to find critical numbers, right, you find derivative and set it to 0. So let's pretend we did all that work. Now set it to 0. So we said earlier, you can just set the numerator to 0. So x would be plus or minus 2. All right. That's step 2. Step 3, I have to do another page. I don't think I have space here. Excuse me. So far, you guys are good. All right. Step 3. Find all extrema points. So basically, test around your 2 critical points and determine if they're maximums or minimums. I'm going to choose 0, 3, and I guess -3. I'm not going to use a second derivative test because finding the first derivative is a pain. Finding a second one would be even worse. So trust me, stick with the first derivative test here. All right, so first derivative at -3 would be -3 squared plus 4 over -3 plus 4 squared. It looks like this would be -9 plus 4. Do you agree that the whole entire bottom is going to be positive? Right, we're squaring the entire quantity, so there's no way this would produce a negative. And the top will be negative. So this is a negative number. I don't care what it is, though. The minus. Derivative of 0, that's the middle now. That'll be 0 squared plus 4 over something squared, so it doesn't really matter again. So this will be positive. y prime of 3 will be exactly the same as this one. So it's going to be minus. Right? So we have decreasing, increasing, increasing, decreasing. So local maximum at 2 something, local minimum at -2 something. So plug in step 4, x equal to 2 and x equal to -2 into the original function. So let's plug in 2. The original was 2x over x squared plus 4, so that'll be 2 squared plus 4. So 2 over 8, right? Y at -2, the -2 over -2 squared plus 4 equals -2 over 4 plus 4. -1/4. All right. Well, we've been doing a lot of nonsense for a bit here. So what are we doing? We are finding the intercepts, the max and mins. Local max, local minimums. That should be enough to sketch. All right. Use all the info to sketch. Let me double check the homework question. Yeah, it should be good enough. All right. So we had x and y intercepts at the center. Right. We had a minimum, no, a maximum at 2, 1/4. So I'm going to say that this is 0.5 and this is 0.25. So at 2, 1/4, we have a maximum. So doing something like this. And then we have it go through here. And that negative we have this going on. Minimum. That's my rough sketch. So in the exam, that's what I want to see is just find your local extrema, your intercepts, and just do a sketch. It doesn't have to be perfect. I don't know how accurate that is. Let's see. Alrighty. Let's look at the graph. So theirs is way better, right? But not bad for having that information. All right. Any questions on the first example? You see they're kind of long, right? Okay. Let's do one more because it's exactly the same thing. This time I'll go ahead and do the inflection points. I don't think I did them last time in the first example. So let's do it here. Yeah, pretty much. There's a lot of techniques to do things without calculators. They used to have, well, they still exist, but nobody uses it. You remember law of sines and cosines? There used to be a law of tangents they would use because it was easier to handle without calculators. But now no one uses law of tan because we got nice scientific calculators. Okay. Yeah, we don't teach law of tangents for that reason, but it still exists. But it doesn't come up as a lesson anymore in our math books. Yeah. But doing stuff by hand still helps learn certain things. So we still do some of it, not not everything. If I can get away with it, I will. But if it's actually beneficial, then I'm going to do it. Okay. Step one, find x and y intercepts. Just plug in 0 for y. Same deal. I believe this should be a square. Alrighty. Um, so again, the only time this will be 0 is when the numerator is 0. So let's put it over here. Okay. Y and y-intercept. Let x be 0. Hmm. Same issue as before. It's going to be going through the origin. Oh well, whatever. One second. Sorry. You put the AC on. It's getting hot in here. Find y prime and the critical numbers. So again, I'm going to skip the derivative steps because if I don't, we're going to add probably 20 to 40 minutes per question. No, wow. Yeah, we're having tons of rain and we had 2 tornado warnings in 2 different areas. Yeah, it's supposed to get pretty cold Sunday, Monday. That's true. But San Antonio is weird. It's gonna be hot again like by Wednesday. At least Halloween will be kind of cool. This should be good. All right. Yeah, I guess so. Never know what's gonna happen, man. All right, set this guy to 0. This will only be 0 when this guy is 0. All right. Critical number right there. Step 3, find y double prime and the inflection point. Y double prime going to be negative 72 times x squared minus 4 over x squared plus 12 cubed. So this will only be 0. So to find the inflection point, we set the numerator to 0. So set this to 0. Divide both sides by negative 72. Solve for x. X is plus or minus 2. All right. So next page, we'll test around 2 and negative 2. It just so happens we got the same thing again. But so far, you guys still with me, right? Set the derivative to 0 to get in critical. Set the second derivative just to 0 to get inflection. We got the intercepts. Now we just got to determine if they're maximums or minimums, and we'll be good. Oh, actually, you know what? Instead of testing, since we already have the second derivative, we could test the critical inside y double prime to determine if it's max or minimum. So y double prime of 0 would be negative 72 times 0 minus 4 over 0 plus 12. This will be negative times negative, positive. This will be positive. So plus. So we said if it's positive, it is concave up. So minimum, right? All right. Plug in x equal to 0, the minimum, define the location. So plug in the original, we'll get 0 over 0 plus 12, which is 0. So minimum at 0, 0, the origin. All right then. Let's go ahead and sketch, I guess. All right, step 3. If you divide both sides by negative 72, 0 divided by anything is 0. So you can just basically remove it. Sorry. Same here, man. Trying my best not to sound exhausted. I'm sure it's not helping. Putting myself to sleep along with y'all. Okay. 0.5 and 1. So we have a minimum right here. We have an intercept there. Inflection point. Well, I didn't plug it in. Shoot. So 1/8 is about what? About there somewhere. I don't know. F of 2, negative 2. So if you remember rational functions, you should know that there's an horizontal asymptote up here. Back from college algebra. So we know it's an opening up here. And then right there, it changes the inflection. It looks like it should be doing this as it approaches that asymptote. Right after this point, it begins to decrease. And goes this way. So this is my inflection points. This is the minimum or extrema, also critical. All right. Using all the information, inflection, minimums, and a little bit about asymptotes, we can get a sketch. So it looks like this guy, right? This is a little better guess. Better sketch than the last one, I guess. Not too shabby. But anyway, the homework's gonna ask for you to give them the intercepts, the minimums, maximums, inflection points, any asymptotes if they exist. And then pick the right graph. On the exam, you'll have to do a sketch, but I mean, a lot of the points would be find the information and then the sketch. Are there any questions on this section? After that, it just keeps repeating itself over and over again. Just find intercepts, inflection, critical numbers, maximum, minimum. Basically the same thing as the last section. We're just applying it to a sketch.
So your points of inflection were that 1/8 and -1/8.
They were at 2 and -2, but when you plug them in, you get 1/8 and -8. So I know it's not really that accurate. This is closer to a quarter, but you get the idea, right?
Yeah. So on the homework, when they're saying points of inflection, then they're asking for the smaller x value and then the larger x value. It's just basically the positive and negative, right?
Yeah, smallest always means the most negative.
Okay, got it. Thanks.
All right. You guys have any questions on any of the other homeworks or any concerns about anything? I removed 4.5, so no worries on that one. Let's see here. I think I already extended everything, so everything is currently open, right? For the most part. You guys need any extensions at this point? But I'm hoping that you're good, but let me know. Alrighty. Let me take roll. Also, there will be no class on Halloween, so feel free to go party it up if you want, or do some homework, whatever you got to do.